My material was writing implements, or more specifically, inks. An ink's application is typically creating a lasting and opaque mark on a surface. Now, inks are divided into a couple different categories. First, they're either a dye or a pigment-based ink. Now, dye-based inks are going to be particles of dyes that combine to create a color of an ink, versus a pigment-based ink is going to be pieces of a pigment itself, which is that color, mixed in with a solvent, which is what we're going to be talking about mostly. Now, independent of whether they are dye or pigment-based, they're also divided into alcohol-based, water-based, or oil-based. Now, comparing each of these things, we're going to be talking about long-term water resistance. That's water resistance for things like water damage and rain and things like that over a long period of time. Short-term water resistance, which is water resistance in creation, such as putting ink underneath a watercolor or something like that. Long-term smudge resistance, that's again going to be its resistance to being damaged by being touched or things like that. And then short-term smudge resistance, which is again smudge resistance in creation. Now these are values that are hard to find just in research, so I did some experiments. So this is several boxes of each type of ink, which in this row immediately after drawing I passed a wet brush with water over, and then allowing 1 minute to dry, passed a wet brush with water, and then allowing 30 minutes to dry. And next to each of them we can see a control line which did not have any water to show how it behaves naturally. That's how we're going to show water resistance. And then down here we can see our smudge resistance. Underneath these pieces of paper are the same box, which again, immediately I wiped this paper across it, or then allowing 1 minute to dry, I wiped this paper across it. And I repeated this not only on art paper, but also on printer paper, parchment paper, and wax paper to show different properties. And then my last material property is going to be UV resistance. So moving on to our alcohol-based ink, which is going to be our Sharpie. We can see for a long-term water resistance test, quite a bit of the dye was picked up by the fibers of the brush. And we can tell that because there's no dye spread out here in the empty space where the water was. It is only taken away where the brush passed. So the bonds with the paper are quite weak and they're quite easily overcome, but the ink itself is not water soluble. Moving over to our short-term water resistance, we can see again quite a bit of the ink was lifted by the brush, but none was spread by the water. And this is done on parchment paper to highlight that despite quite a bit of the ink having been lifted, there is still a remarkable amount of it that remained. Now for our long-term smudge resistance here, this is a little misleading. This was done on wax paper, but I wanted to highlight the weakness of alcohol-based ink as it is quite weak in its bonds with the fibers of the paper. So this was done on wax paper, which it cannot really bond with at all. And even after being almost completely dry, when wiped, it quite easily broke and came off with the paper. Versus here on our short-term smudge resistance, this was probably done on printer paper, which bonds easily with the ink. We can see even though it was smudged immediately, there is functionally no ink left on the paper. Moving up to our water-based ink, which is going to be the Micron, we can see that for our long-term water resistance test, there's absolutely no change between this control line and this test line. There is no ink picked up and spread out with the water, and there is no fading. Water-based inks bond very, very well with the fibers of the paper. However, especially compared to our Sharpie, water-based inks have a quite slow dry time. So we can see here that all of this wet ink was very easily picked up and spread around by the water. It's obviously a water-soluble ink, but looking closely, we can see no spreading. Whereas compared back here again to the Sharpie, we can see some amount of spreading and damage from the paper being wet. Moving down to our smudge resistance, we can see a little bit of smudging as it was not completely dry. It was only dried for a minute, but again, it is quite well bonded. And then compared to our short-term smudge resistance, if we remember it dries quite slowly, we can see quite a bit of smudging. Now for our long-term water resistance on our oil-based ink, which is going to be the Uniball, we can see absolutely no change from the water once the ink was dry. And that is because as an oil-based ink, it is actually water repellent, not just water resistant. Versus our short-term water resistance is again on wax paper. We can see that some of the ink was, like the Sharpie, picked up by the brush and absorbed into the fibers of the brush, but it was not spread out with the water like we saw with the Micron, or that we can see with the Micron here. Now for our long-term smudge resistance, we can see that a bit of ink is transferred here as oil-based inks have a very slow dry time. And we can see that again on our short-term smudge resistance. It was absolutely wet and almost all of it was picked up because again, it has a very, very slow dry time. That's the end of our solvents. We can move on to our UV resistance. Now this was not done by me, as this took 5 years. This was done by the wonderful Chris Breyer from his website. UV resistance is almost entirely determined by whether it is pigment-based or dye-based, and especially the type of the pigment. So this experiment was conducted by taking this piece of paper and cutting it in half, and this half of the paper was left in his car in the sun for 5 years, and this half was left in complete darkness. So we can see here our Micron was completely unchanged because it is a pigment-based archival ink. And again, a Uniball also is pigment-based and archival. However, Sharpie is dye-based, and as we can see, it is absolutely destroyed by the UV.